Good morning, students. In the previous two lectures, in lecture 1, we discussed about the various aspects of Brayton cycle briefly, the classifications of gas turbine cycles, the effect of pressure ratio on the cycle efficiency, and in lecture 2, we discussed about two methods, intercooling and regeneration, and their effect on the efficiency of the cycle. Some pros and cons were discussed, and in this lecture, this will be a short lecture, we will discuss about the effect of reheat, that is the third method that we discussed about, on improving the thermal efficiency of Brayton cycle. So let us start. So this is the cycle. Here this is a single stage compression. One compressor is used and a reheat is adopted over here. That is, in first stage turbine, after the expansion, heat is added and temperature is raised, and then the working fluid is fed to the second turbine. This is the flow diagram, and the total, that is the total heat supplied, is given in two stages, and the expansion process be divided in stages in two turbines T1 and T2 with intermediate reheat as shown in the flow diagram. Right? The work capacity increases, but as mentioned, heat supply also increases. So let us discuss about it briefly. If you look at the figure 1, 2, 3, 4 dash, 1, 2, 3, 4 dash, this was the basic cycle in the same line and without reheat, and after this is the reheat, 4 to 5 is the reheat given in the reheater, and after reheat this cycle, that is the 4, 5, 6, 4 dash, is added to the basic cycle 1, 2, 3, 4 dash. So work area is higher, so work obtained is more. So the work capacity increases, but note that the heat supply also increases. Earlier the heat supply was 2 to 3 constant pressure heat addition, but now heat supply is 2 to 3 plus 4 to 5. In the cycle 4, 5, 6, 4 dash, in the cycle as in 4, 5, 6, 4 dash, RP is lower than the basic cycle, so its efficiency is lower. Therefore, the efficiency of the cycle decreases with the use of reheat. But T6 is greater than T4 dash. T6 is greater than T4 dash, right? Therefore, if regeneration is employed, there is more energy that can be recovered from the turbine exhaust gas from the point at T6, right? So, when regeneration is employed in conjunction with reheat, there may be a net gain in cycle efficiency. So whether the cycle efficiency increases or decreases, the answer is only reheating reduces the overall thermal efficiency of the cycle, but as T6 is greater than T4 dash as seen, therefore if regeneration is employed, there is more energy that can be recovered from the turbine exhaust gas. Okay. So let us now come to a ideal regenerative cycle with intercooling and reheat. So as discussed, to increase the overall cycle efficiency, we need to apply regeneration along with intercooling and reheat. So this is the intercooler where the after compression temperature at T2 is brought to the initial temperature of T1, that is T3 after intercooler, T3 equal to T1, and then that is fed to the second compressor, and after the compressor, the heat is initially heat taking from the turbine exhaust is utilized in heating up the air from the second turbine, second compressor outlet, and then heat is added in the combustion chamber, right? Then it is fed to the turbine, and after initial expansion it is again sent for reheat, and then it is sent to the second turbine, and the cycle continues. And using the regeneration, and after the heat rejection in the second heat exchanger, in a closed cycle, the temperature is brought back to initial temperature and the cycle goes on. The corresponding TS diagram is like this. The 1 to 2 compression, 2 to 3 intercooling, 3 to 4 second compression, 4 to 5 to 6, that is the heat addition, 6 to 7 first turbine, 7 to 8 reheat, 8 to 9 second turbine. So the applications we discussed that applications of gas turbines are mainly in aircraft and industrial turbines. Three aspects: the size and weight of the aircraft power plant are very crucial compared to industrial units. The aircraft power plant can make use of kinetic energy of the gas that is leaving the exhaust, whereas it is wasted in other types, and consequently the energy lost in the exhaust in the industrial gas turbines must be kept as low as minimum that is possible. Industrial gas turbines are rugged in construction and with many auxiliary equipments. They often employ large cylindrical combustion chamber. They are also designed for multi-fuel capacity, right? So we end the discussion on the gas turbine part, and in the next lecture we will start the topic on jet propulsion. For the time being, we stop here, and thank you very much.